Hi, the next step I will explain in process validation is an example of an operational qualification. This is a simple example. Further lectures will give more detail. This allows the learner to understand the basic concepts. The learning objectives for this lecture is as follows. I will demonstrate an example of an operational qualification. I will show how process parameters are established which enable the output to meet the user requirement specification. I will explain how input process parameters are developed. I will explain how outputs of the machine are developed. I will explain how to create an upper and a lower control limit for the process parameters. The example I will use is an operational qualification for a bond welder. This is a typical machine that is used in the medical device industry. The bond welder is one step in a process that creates a product called a catheter. This is a delivery mechanism for coronary stents. Stents are a treatment for occlusions in the coronary arteries of the heart. The catheter contains flexible pieces of tubing that is bonded by heat and pressure. Figure 1 demonstrates an overlap bond weld. Here is an example of a bond welder that is used in the medical device industry to join two pieces of plastic together. What is needed to complete the process? Heat, pressure applied by the jaws of the bonder, and a dwell time to allow the process to occur. These three variables, which are our process parameter inputs, will produce an output. In this case, the output is a bond with a certain tensile strength. So, here are the details that constitute an overall operational qualification. In our example, we need to consider the raw material specification. There are two pieces of PVC which need to be specified and therefore will become part of the overall validated process. In our example, we state the white material is PVC, polyvinyl chloride, part number 1234A, and the grey material is PVC, polyvinyl chloride, part number 5678B. This will be the material that will be used in the process validation. The operational qualification will state how the process will be operated. The operational qualification will create a procedure, in this case SOP 001, and it will reference the owner manual for the source of its information. How we handle the material for the process will be documented and procedures will be created. In the example, a raw material and finished product handling procedure was created. Training procedures on how we operate the bonder and how we operate the bonder will be created as part of the operational qualification. In our example, SOP 002 is created. How do we verify the output? The verification is that the bond strength must be able to withstand a tensile strength of 50 kilonewtons plus or minus 1 kilonewton. How do we confirm this? We perform a destructive test using an Instron tensile tester following a standard test method. In this case, we use the standard operating procedure 005, which will explain how the test is to be performed. Now, let's look at the machine inputs. Temperature, dwell time, and pressure. We need to create initial process parameter inputs. We can gain this information, for example, from the supplier of the machine. In our example, we start with 95 degrees Celsius for the lower control limit to 105 degrees Celsius for the upper control limit. We can also reference the initial process parameters from technical literature. So for example, the other two initial process parameters are a dwell time range from 25 seconds to 35 seconds and a pressure range from 45 megapascals to 55 megapascals. The machine input process parameters were set at low, medium, and high settings. So for example, the low input process parameter settings were as follows. Temperature input process parameters set at 95 degrees Celsius. The dwell time was set at 25 seconds. The jaw pressure was set at 45 megapascals. The input process parameters were also set at a medium setting and a higher setting. In each manipulation, a sample which contained 20 pieces was ran through the bond welder. A destructive test was carried out for each piece within the sample. The data showed that all the pieces in the low setting and the medium setting passed the destructive test. It was observed that 5 pieces from the sample of the high process parameter inputs failed. So the low setting and the medium setting passed the objective of the operational qualification. Another iteration was performed at the higher setting. In this case, the temperature was adjusted to 103 degrees Celsius. The dwell was set to 33 seconds and the pressure was set to 53 megapascals. Another sample of 20 pieces was ran through the bonder and a destructive test was carried out. This time, all pieces passed the test. This allows us to determine that the upper control limit for the input process parameters is 103 degrees Celsius, dwell time 33 seconds, and pressure 53 megapascals. So, what have we concluded? We determined the input process parameter control limits. As we can see, it is the following. The nominal temperature setting is 100 degrees Celsius with a lower control limit of 95 degrees and an upper control limit of 103 degrees Celsius. The nominal dwell time is 30 seconds with a lower control limit of 25 seconds and an upper control limit of 33 seconds. The nominal pressure is 50 megapascals with a lower control limit of 45 megapascals and an upper control limit of 53 megapascals. We have also developed a procedure to ensure settings are achieved for the nominal parameters. We've created specs for the output of the process. We've created specs for the material to be used in the process. We've created procedures how to operate the machine and training records. What have we learned? In the example of the operational qualification of a bond welder, we now understand the following. The process input parameters of this bonder. This has led us to understand the inputs into an operational qualification. We now understand how we can determine upper and lower control limits of the input process parameters. In this example, we have learned how to verify the outputs.